Right. So today I'll be talking about operationalizing Golangci-lint. This is the agenda for the talk. I'll be covering, I'll be starting with a brief introduction. I'll talk about what is a linter. Some of you are new here, so I'll be giving a very brief introduction. I'll also talk about why you would want to use linters. Then we'll look at some examples which hopefully should show the value of using linters. And then finally, we'll talk about how to use Golangci-lint. So I started working as a software engineer in 2012, and I did not start in Go. I started working in Go at Redbus, and I also worked in Go at Gojek before my current company. I've done a little bit of open source as well. I'm not that active now, but I still do a little bit of maintenance on this tool, which can actually generate implementations, mock implementations from interfaces. And I'm currently working as a staff engineer in the SaaS security posture management team. So SSPM is a tool that helps protect cloud apps by finding and fixing security risks. By the way, Netscope is hiring. So if you're interested, please check out our careers page. All right. So what are linters? The term linter actually originates from a Unix utility. That's just a small bit of history, but a linter is basically a program which can do static code analysis. By static code analysis, what we can understand is that it's not executing the code to understand if there is any issue with it. And in simple terms, you can basically think of it as a program which can identify and flag predefined patterns. So these patterns are basically what we consider as of interest. So it really depends on the person writing the linter, but it can flag such patterns. And these patterns can either be related to potential bugs or code style. I personally came across linters the first time when I was working in Node.js. And in Node.js, as far as I know, one of the most famous linters is ESLint. And when I came across ESLint, I went through all the rules that it supports. And I learned a lot about the language because it is basically trying to protect you from all the pitfalls which are inherent to JS, right? It's a language which has a lot of quirks. So the rules which are present in ESLint actually kind of helped me realize that they are there, right? So it completely changed the way I wrote code. But why would you want to use linters? So one of the most important aspects, I think, is the idea of shift left testing. So if you think of the feature lifecycle, we have product gathering, architectural design, implementation, unit tests, integration tests, UI tests, right? And the basic idea of shift left testing is to move the issues left when you consider these steps, arranged sequentially. And the main advantage of doing that is you get to catch issues early. And in almost all the cases, if you catch the issue early, it will be cheaper to fix that issue. Issue that you catch in production is typically going to take you longer to fix compared to something you're able to catch in your unit tests, right? So this same idea can be applied to linters as well, where we can move the detection of issues from unit tests to linters. And when I say linters, I don't mean something which runs in CI, right? Ideally, linters should be able to give you real-time feedback while you're working on something. And that has immense value because it saves you a lot of time. So this faster feedback, right? I mentioned here it gives you improved quality and speed. It must be intuitive why that is the case, right? So if it is able to detect issues which you might not have caught otherwise, you will be able to fix it immediately. And that means you have this faster timeline for delivering a working change, right? And the quality is obviously higher because there might still be issues which you might not have caught even when you wrote your unit tests, tested everything, and delivered it to production. I'll be showing some examples which might give you an idea of how that could be. So this, I think, is one of the most important reasons of why you would want to use linters. We also have code style, right? So when I say code style, I'm talking about consistency for your code constructs and the type names, package names, etc. One good example of that is the Effective Go guidelines. Effective Go is a must-read page for anyone and everyone who is interested in Go. It's maintained and written by the official Go team. It has a lot of very, very well put together ideas and thoughts around how you should actually work on Go, and I would highly recommend checking it out. But it also has some guidelines on naming packages. And the advantage of actually following these guidelines is that you get to have consistent code, irrespective of who writes that code. It could be you, it could be your teammate, it could be a different company altogether. The idea of having this basic guidelines which help you bring consistency to the code immensely helps readability. So I have worked in multiple languages. I have worked in Python, Java, and Node.js. And in all of the other languages, my personal experience was that I always found it difficult to actually read the library code. You typically use a lot of libraries. Nobody writes everything from scratch. And I always found it difficult to understand the library code because it's a slightly different language altogether. Yeah, it is JS, but you can write JS in so many different ways that you might as well consider it a sub-dialect. Whereas in Go, I have always been able to read most of the libraries because they are always written in that consistent manner, formatted in that consistent way, and that makes a huge difference. Over here, I've also mentioned again, faster speed of delivery. So I'll give you an example of how that can happen, right? So let's say one of your teammates raises a PR, right, pull request, and you happen to notice that there are a few unnecessary new lines, right? At the end of the function, there are some new lines. In the interest of keeping the code clean, you ask him to clean that up, right? And now you have this very small round trip of you actually adding that comment, that person addressing that comment, that CI has to run again. All of these small things actually add up in the long run, right? So having this consistent code style which you codify, which you codify and are able to apply for everyone working on a particular project, again will help with speed of delivery and avoid inconsequential debate. So there's a lot of things that we can argue about, right? And there is sometimes good points on both sides, but in the interest of actually getting things done, it's better to just pick one and proceed. And that is exactly what Go did with GoFumped. So GoFumped is a tool, official tool for formatting Go code, and pretty much everyone uses it. And it chose tabs over spaces and ended that debate completely for the Go community. And that is again something that will save you time, which you can use for actually getting work done. Apart from that, linters can also act as guardrails. So this is beneficial for both experienced as well as new developers. It's not really possible to remember hundreds of different things which you need to keep in mind while you're trying to implement some logic, even for an experienced developer. But it is that much more helpful for a new developer who can discover all of these nuances around a language because the linter is helping point them in the right direction, right? And also one thing I want to call out is that some of these linters, right, they're also able to catch issues which you might not have caught in tests either. They're not directly related to functionality sometimes. I'll talk about that when I go through the examples. So to try and drive the point home of why you would want to use linters, we are going to look at some examples, and I'm going to show some code snippets, and I want participation from audience to try and spot the issue, right? The examples are a bit contrived, but the purpose of this discussion, that should be okay. All right, so to begin with, right? It's already running. Sorry, this was supposed to be something else, right? So this example, if you see, I have this very simple struct, and I'm trying to format it as a string, right? And over here, I have this function, sprintf call, which is formatting the value as a string. So I kind of gave it away because I had done some changes before, but the problem is basically we are using %s over here, which is meant to be used with a string, right? It's a formatting verb, that's the term used, and it is %s over here. So if I were to run this code, the string wouldn't be exactly the way I would expect it. So if you see over here, fmt sprintf doesn't have the option of returning an error. So it does the best it can to indicate that something was not right. If we instead change it to %d, then it will work as intended. Yeah. So for this, we do have linter, right? I'll talk about that soon. So let's start with the first example. So over here, I have a pretty simple, block of code. I have an error type which implements the error interface, right? It's called myError, and I have this demo function where it is calling a do something function, which returns an error which may or may not be of type myError. Okay, sometimes under some circumstances it returns myError, and what I'm trying to do is I'm trying to check if it is of that particular type. So in Go 1.13, there were changes made to the library which introduced these functions errors.ease and errors.as. Errors.ease can check for equality. Errors.as can check if the given error includes an error in its chain which implements that particular type. So we have the option of wrapping errors. You can use fmt error f, for example, and use the formatting verb %w, and that would result in a wrapped error. So this errors.as is capable of unwrapping errors and checking if any of the errors in that entire chain is of that particular type. So can anyone spot what is the issue here? Yes. Yes. So over here, the fix is to instead use pointer to myError, and the reason for that is we implemented error on the pointer to myError, and errors.as expects you to pass the second parameter to errors.as should be a pointer to a type which implements the error interface. And for this, we have the check available via GoWet. GoWet is again maintained by the Go team. And as it happens, whenever you run Go test, it actually runs a subset of the checks present in GoWet. One of those checks is errors.as, and you can check the documentation on each of those checks via this command, and it pretty much says the same thing that I was explaining. And we can also get the same error via a linter as well. So it clearly calls out the file and line number and everything where we are doing that mistake. Okay, example number 2. So over here I have a function which is interacting with the database. I'm making a call to the database with a query. The query is pretty straightforward. I'm selecting 3 columns from the customers table, and I'm then iterating over the rows and collecting all the returned rows into the customer slice. I'm doing the append over here and I'm returning it, right? But there is a problem in this. I'll come back to that. I can run it again. For demonstrating this particular function, I have these 2 helper functions. So print customers is a function which is going to just call fetch customers and print all of them. There's nothing wrong in this code. It is using the right format verbs. And I have another demo function which is running the same function twice. It's calling print customers one time here and the second time here. So you would expect that we would get identical behavior for both calls. The query has not changed, nothing has changed as such, right? But if I were to run this, we get slightly different output. The first attempt we got 5 rows, in the second attempt we got 3 rows. So can anyone spot what could be the issue in this code which is resulting in that? No, that's not really happening. So we are actually initializing the array over here, right? It's a nil slice, and we are appending to that slice. That's not really the issue. I am closing the rows here. One improvement that could be done is that I could catch the error if it returns an error and I could log that. But even if I were to do that change, it wouldn't fix the issue in this case. Returning nil where? So you mean this one? So the thing is, if it were to return an error, you can see that I'm actually propagating that error correctly. So fetch customers, if it were to return an error, I would return an error from print customers, and print customers would actually print the error. It would return the error and we are printing that elsewhere. So that's not really the issue. Right, so the problem is we are not actually checking, we are missing one error check. So, okay, all the demos are already live. So over here we have a linter called rows err check, and if we were to run that linter, it would say that rows.error must be checked. And the change required is just this simple. After you're finished going through the rows, you need to actually check the rows.error. So in this case, obviously I cheated a bit. I'm not connecting to an actual database. I have a mock database which is used for reproducing this. So now if I were to run the same this code, we can see that it actually prints the error, which says that it was a rows iteration error due to context deadline exceeded. The context deadline exceeded is a mocked error, but this can very much happen with your real code as well. So you might expect that the context that you specify over here is applicable only for the DB call. But that's not what actually happens. What happens is that this context is applicable for this rows iteration as well. So if, let's say, your query returns before your context deadline is exceeded, but the context deadline gets exceeded while you are iterating the rows. Maybe you have iterated 1, 2 out of 100. And at that point, if the context deadline gets exceeded, it will actually return false. Rows.next will return false, and you need to check rows.error to know that something went wrong. If you don't have that check, then you might be returning incorrect information back to the user without having an indication that something has gone wrong. So this is a example of something which you might not test in your unit tests. It's hard to reproduce this with a real database, and even if you're using a mock DB, you need to know in advance that there is this API which I need to actually set up the mock for. Okay. This is a pretty simple example. I'm trying to build a URL. That's all I'm trying to do. And I have some search parameters. This is obviously just for the purpose of this demo. I have put in some parameters over here, and I've parsed a URL from this particular domain, and I'm calling set query parameters, right? So that function is here, and I'm calling set with different parameters 3 times. So this is what I expect, right? The URL should be of this format where there are 3 query parameters. But if I run this now, what I see is actually pretty different. Does anyone know what's the issue? Can you speak up? Yes, yes. So the right answer is that when you actually call u.query, it returns a copy, which is not going to actually do any change on the URL instance. So static check, which is an excellent linter, which has many detections. One of the detections is for this problem, and it will clearly tell you that when you call query, it returns a copy, and modifying it doesn't change the URL. So the way to handle that is to instead take out the query, set the query parameters, and then encode it and set it back into the URL instance. So if we do this, then the URL should be as we expect. This is the last example. Over here, I'm making a HTTP request. The details are not that important. I'm making a API call to HTTP bin. But in your real application, you could be making a API call to some other service that you're dependent on. And after the response is returned, I'm checking the status code, I'm reading the response body, and then doing something with it. In your actual application, you might be marshalling that response body into a value and using that as needed. So can anyone spot what is the issue in this code? Yeah, seems like a lot of people are aware of this one. So there is a linter body close which is capable of catching this issue, and it mentions that request body must be closed. So over here, after we finish hc.do, hc is the HTTP client. Once the response is returned and there is no error, we need to actually call close on that particular response body. And documentation is very clear about this. It clearly calls out that it's the caller's responsibility to close the body. The default HTTP client's transport may not reuse keep alive TCP connections if the body is not read to completion and closed. And if you're missing something like this, it can actually have serious impact on the performance of your application. You might exhaust certain system limits which are present on the number of connections you can create. So missing this is actually can be a serious problem. And over here, we have this defer function, which is draining the response body and then closing the response body as the documentation suggests. So there is one small missing feature in the linter, which is that if you were to have a named function, so this anonymous function that I have deferred over here, if you instead had a named function which you were calling over here, it would still flag it as a false positive. So that is unfortunately a small drawback of this linter. All right. So now we have talked about what is a linter. Yeah. That's not the case. Okay, I don't know the specifics of this one, but what I know is that if you don't close the body, the connection will not be reused. So if you want connection reuse, you need to drain the response body and close it. But if you are using that same connection for doing a lot of back and forth, then maybe the rules are different. But I completely agree. It depends a lot on the specific application. Yeah, most of the cases, this is what we need. Yeah. So over here, I have an anonymous function, right? So imagine I moved this to a named function. Like I said, I'm going to define a function called drain body, which had just these two lines, to which I would pass the response body. The function would take response body as a parameter, and it would discard or drain the response body and close the response body. So if I were to instead have that function, which I then deferred over here, body close will still say that response body must be closed, which is a false positive. Okay, so we've looked at what is a linter, why you would want to use linters, and we also looked at some examples which might give us an idea of the importance of linters, right? So, but let's talk about linting in the context of Go. Like, what does it mean? What do we need to do? So in this, I'll be basically covering these aspects. I'll talk about why you would want to use Golangci-lint. Why do you need to spend extra effort to try and configure Golangci-lint? We'll also look at a sheet, Google Sheet, which can help you actually build that configuration. And finally, if we have the time, I'll also talk a bit about project tooling, which is basically useful for developer experience. So Golangci-lint is a linter aggregator. It basically allows you to run multiple linters with a common interface. You configure everything through a single file or via command line arguments. And when you get the output, it is all in a consistent format. But under the hood, it actually does a lot of work to keep it very performant. Is there anyone here who remembers Go Meta Linter? It used to be popular, way back in 2018, and that was around the time Golangci-lint was introduced. But it was a huge noticeable improvement when Golangci-lint came out, because it started reusing a lot of the work that is common to linters. A lot of the linters under the hood will actually use the analysis information of code, right? Go has actually capability of delivering like the AST information and all that, and all of these linters work on building on that. So Golangci-lint basically takes care of doing whatever work can be simplified just once, and then parallelizing it to the extent that is reasonable. There are actually configuration parameters which you can use for determining what concurrency you want, but overall it is very performant, right? And also it is very popular. You can see, I've just taken a screenshot here. It has actually a good amount of very well-deserved stars. It also has a lot of forks, and it is actively maintained. Usually if you have some issue, they are very responsive. And just in the last month, you can see they've made 3 releases, and they have merged a lot of pull requests and also closed a lot of issues. So overall, it is a very, very well maintained project. And they also have a lot of additional support, like being able to run Golangci-lint via actions. They have a officially maintained tool which can actually help you do that. So just run Golangci-lint in your project and just use whatever information it outputs, right? Unfortunately, again, no. By default, Golangci-lint integrates, although it supports 100 plus linters, it enables just these 6 linters. These linters are definitely useful, but it leaves a lot of things on the table. So, these are some of the examples of very useful linters which are not disabled, which are not enabled by default. So ErrorLint, for example, can help you actually transition from the old way of checking errors, which was to use equality and type assertions, to instead using errors.ease and errors.as correctly. And GoCognite is another really useful linter to have, because the way it works is very interesting. So it actually computes a score for each and every function that you have based on the number of if conditions, nesting, for loops, that kind of thing. And based on that score, it will output a linter error, whether something needs to be fixed or not. So in that sense, it can help you maintain your code base in a manner where it doesn't become too complex. You ensure that there is no function which is unnecessarily complex. It is broken up into smaller functions and things like that. We also have, GoSec deserves a special mention. It can inspect the source and flag security issues like SQL injection, command injection. So it's a really, really useful linter, which I highly recommend. And we also looked at rows ERR check, where it was a linter which can actually catch issues with you checking the rows error. And similarly, there is SQL close check as well. So one thing I want to mention is that there are actually 2 types of linters which Golangci-lint integrates, right? So there are some linters which are more focused. They are concerned with the specific problem statement, and they restrict their checks to just that. But then there are also linters like GoCritic, Revive, Static Check, which actually include a very wide variety of checks. And those are GoCritic and Revive are not enabled by default. So there could be a lot of useful rules which might benefit you. So what is the answer? Should we just enable everything? Again, no. If you enable everything, you will again face some issues, because you might end up with a lot of noise. There will be linters which are not really something that you would want. Some of these linters are very opinionated. I'm not saying it doesn't have value, but it really depends. You as a team or as an individual have to decide whether you see value in that, and then decide whether you want to have that. Some of these linters are also dependent on the specific usage. For example, we have this linter called zero-log-lint, which will actually lint your usage of the zero-log logger. It's a logger which is meant to be used in high-performance requirement kind of environment, but that linter is basically useless if you are not using zero-log-lint. We also have the problem of duplication, because with the number of linters that Golangci-lint supports, it's kind of inevitable that there would be duplicates. I actually, when I had worked on figuring out the right configuration, I was able to identify more than 40 duplications across all the linters. In some cases, it might also be premature optimization to enable certain linters. Like for example, pre-alloc is something which can actually help you avoid making allocations, unnecessary allocations when you're working with slices. It basically asks you to pre-allocate. So this is a really useful linter in my opinion, but at the same time, I don't think most people need it, right? In some sense, we saw earlier an example where I was just initializing the slice, with just the nil slice, right? That works well for most people because most people are not really dealing with slices which go into hundreds of thousands. They are definitely there, and for those cases, it is good to have that optimization. But at the same time, you would want to avoid premature optimization. So with all of what I've covered so far, right, I hope you agree that we need to put in some work to configure Golangci-lint. But yeah, there is still one more aspect which I want to cover, which is that for the linters that you enable, you might need to configure it specifically. Like for example, this is a configuration for GCI, which can ensure that you have deterministic package import order. It can basically break up your imports into individual groups, and whenever you run GCI, it will format all the files to have this consistent order. So over here, I have basically 3 groups. There is standard, which is the standard library, default, which is anything that doesn't match the other groups, and I have a prefix, which will group all of our Netscope internal packages into a common group. And this is the setting for GCI, right? So even for linters like GoCritic and Revive, you would need to actually do this work because they have a lot of checks, and you might want to actually have the check for a subset. Like you might want to select 40 out of the 100 plus rules which are available in GoCritic. So now I'll talk about the configuration builder sheet. So in this sheet, basically it is capable of building 2 variants of configuration for Golangci-lint. So why do we need 2 variants? So in my opinion, we have basically 2 performance characteristics when we are running linters. One is when you're running it in IDEs, you need really quick feedback. You don't want to be notified about an issue after you've moved on to a different file, right? On the other hand, in CI, when you're running your builds on a server, you don't have that constraint. You can afford to actually run that intensive check, and it can take a bit longer, but you would want to ensure code quality is absolute before you merge that in, right? So over here, the Golangci.toml is meant for local development and testing. It will actually exclude some of the checks which are intensive, and Golangci prod.toml is meant for CI. And these are some examples of linters which are enabled only in the prod variant. So in this sheet, the first 3 sheets are somewhat similar. I basically have a linter, some basic information, whether it is enabled or disabled, and comments and settings, right? So over here, either a linter is enabled in both local and prod, or it is enabled only in, I think I screwed this up, sorry. I can't edit this now. I'll check this later. I meant to enable this. I ended up enabling this by mistake. So over here, you would either enable both, or you would enable only in prod. And as I mentioned, there are comments sometimes to explain why a particular linter is enabled or disabled. And there is also the settings, right? So these are the 100 plus linters which are available in Golangci-lint. Like, yeah, there are 106. Right? And this is again something which is specific to our usage. I'm not saying this is the definitive configuration you should follow, but this might be a good place to start. And the second sheet has the rules which are supported by GoCritic. So all of this configuration was done for a specific version of Golangci-lint. It has not been updated since 1.57.1. That doesn't mean you can't use it with the newer version of Golangci-lint. It just means that if you are planning to integrate this, you might want to check which are the new rules and linters which have been introduced since 1.57 and add those in if you want to enable that. So over here, as I mentioned, it's again a similar sheet. There is the rule, the information about the rule, whether it is enabled or disabled, and there is settings. Third sheet is similar, just for Revive. So Revive also has close to some, I think 77 Yeah, it has some 77 rules. And as I mentioned, some of these are actually duplicated. So for example, this particular rule is actually already covered by style check, which is another linter which I've already enabled. And some of these things are covered by gofumpt. Gofumpt is a slightly more strict variant of gofmt. And in my opinion, it is well worth to actually integrate this. It has good support in most IDEs as well. And then we have this two sections, the header and the footer section. Yeah, nothing special here. And finally, we have this sheet, which is generated from all of the sheets before it. So all of the information that we have in these 4 sheets is actually used for populating this. Let me switch to a different user. So over here, if we check now, so over here, whenever you update the sheet, it will actually regenerate the configuration and update it here. So that way it's really easy to actually take out the configuration when you want to integrate into your project. This might be a bit of an over engineering, but I had some time and I thought I didn't want to actually spend the effort of trying to translate the sheet, which is really useful for discussion. Like having a single file which only has the rules which are enabled is actually harder to discuss with your teammates. But this way of organizing that information is better, where you can decide whether something needs to be enabled or disabled. This is just bonus, being able to generate the config from it. Yeah, so there are 2 variants, the one with local and the other for prod. Any questions so far? Okay. Yeah. So it's dependent on the performance characteristics. Is that your question? Like, how would you decide if some linter is enabled in local or prod? So see, it depends on where you try to use that configuration. So this particular local configuration is automatically picked by Golangci-lint when you run it without specifying the configuration. And also it is used by the editor integrations, right? So whenever you are doing development, this is the file which will get picked up automatically. But you have the option of specifying a different configuration when you run Golangci-lint. I will show an example later where you can just specify the file which you want to consider for the configuration. So that way in CI you can use the second file. Basically you maintain both of these files in your repository and you use the 2 files depending on where you are trying to run Golangci-lint. Does that answer your question? Mm-hmm. It's not separate versions. It's depend. I mean, yeah. So speed. Speed is the answer. I specifically mentioned, right, these are linters which are typically slower. I had actually run some experiments. I had a bunch of code, checked out, and I ran some of these linters, individual linters, without using cache, and then checked how long it takes to actually complete execution. So based on that, I identified which are the slow linters, and only those linters I have enabled it only for production. Does that answer your question? Okay. So hopefully, yeah, yes. To some extent, yes. So usually they release a new version whenever a new version of Go is released, because there will be some changes in the language which actually prevent you from using the older version. But if you are using the configuration that I've specified, right? So one of the things that I also wanted to mention is that by default we disable all the rules and then choose specifically the rules that we want. And by doing this, we ensure that even if you were to change the version of Golangci-lint, the output would not be different for you. So although the configuration was actually done for an older version, you can use that configuration with a newer version of linter. I mean, if there are new linters which have been added since that version, it won't catch that. Right, so there is already a linter for that. So there is actually a linter, I believe it is copy loop var. So this is a linter which is only meaningful after 1.22. So you have to actually take that slight effort of tweaking your configuration. You don't need to necessarily come here and update it each time. You use this for getting started, and typically after you have the configuration, you would just copy that to your next project, and that's fine. So you would tweak that configuration for each project. This is just a way to get started because it can be a bit overwhelming, knowing about all the duplications and everything. Yeah, 10 minutes. Okay. They can. I mean, you can actually work around that by using pre-commit hooks. I'll talk about that. So now let's say that you have this configuration, right? But what if you have a project which has been in development for more than 1 year, right? Maybe even more. So now if you try to integrate this new configuration, what will happen is that you will get hundreds of errors being reported, which is not really feasible to fix in a single. Sorry, I meant to shift to the slide. Yeah, so it's not really feasible to fix everything in a single shot, right? If you choose to allow the linter step to fail in CI, I can guarantee you that no linter error will ever get fixed. It's a common phenomenon that any CI step which is allowed to fail will continue to fail forever. Nothing will get fixed. So again, over here, Golangci-lint has a really nifty feature, which is that it can allow you to actually compare against a specific Git revision. So over here, they have this flag new from rev. So for new from rev, you could either specify, one commit before head, or you could use your main branch origin/develop origin/main, and it would report issues only for the lines that have been modified, any new or modified lines. So that way you get to iteratively fix all the issues in your code base, right? And even the official GitHub action actually has an option called only new issues. And this works differently depending on the context again. So if it is within a pull request, it will detect the changes being made in that pull request specifically and report issues only for that. So using these two features, right, you can ensure that you can improve the quality of your code iteratively. You don't have to do it in one shot. You might, integrate the configuration with this flag and let changes be done gradually over the course of 1 year or so, at the end of which hopefully you have fixed most of the issues in your code base, at which point you can take one more task to fix all the existing issues. So that can be a really good way to ensure that you are able to improve the code quality of your application over time. Apart from this, there are a couple of things which I would strongly recommend. So as I mentioned, for linters, I think it is mandatory to an extent to ensure that you're able to get the feedback right in your IDE. There is no reason not to do this. Golangci-lint actually has a dedicated page which talks about how to actually set up the editor integration. Most editors like IntelliJ and VS Code actually have native support for this linter. So you should definitely do that. That way you will get feedback right when you are working on something. And also, if you are using a different formatter apart from GoFMT, then you should ensure that even for that, you set up the linter integration, editor integration. And apart from that, for Git, there is this concept of hooks, which can run before and after any command that you execute. And that is a really useful concept which you can make use of for linters as well. So ideally, you would set up a pre-commit hook which runs just before it actually commits the changes. So when you run git commit, it would run some scripts, and if those scripts actually return error, then it would abort the commit. That way you wouldn't be committing and pushing something to CI which is having an issue. So you can use the local variant of the configuration for doing your development, but when you're committing, it can do these additional checks and ensure that the code quality is good enough that it will pass in CI. I think I've run out of time, so I'll be skipping this section. Yeah, so just to summarize, right, we talked about what are linters. They are basically something which can detect predefined patterns. We looked at why you would want to use linters, shift left detection, and improving the quality and speed of delivery, improving readability by bringing consistency. Then we looked at some examples which hopefully demonstrated why and how linters can actually catch really tricky issues. And I also tried to explain why I think you need to do some work to actually configure Golangci-lint a bit thoroughly. And we looked at the configuration builder sheet, which can help you get started. And then finally, we looked at, for existing projects, how best to go about integrating an extensive configuration. Right. So I want to, specifically mention a huge thank you to all the maintainers of the various linters and also the authors of Golangci-lint. The work they have done has saved everyone a lot of time and effort. So for that, a real big thank you. And finally, yeah, so if you're interested in the talk material, you can either scan the QR code or go to this link. And it's a GitHub repo which has all the talk material. Any questions, please go ahead. Yep.
Long strings in 2 lines, multiple lines.
No, actually.
One more. So can you recommend some commit hooks?
Commit hooks, pre-commit hook. I mean, I don't think I understand the question.
So we have
yes, as part of your pre-commit hook, you should ideally run your linter and tests. I feel that is sufficient.
Hey, thanks, Suras. My question is, in linter, is it possible for us to specify that what folder structure should be only restricted to lint analysis, rest others should be discarded?
Yes. So they have a good section on how to actually avoid false positives, etc. So you can choose to disable particular linters for particular file patterns. Like you can say any file which ends with _test should not actually enable these linters. Or you can say that these entire folders should be ignored, right? So they have a lot of capability in the configuration file, which allows you to decide which particular folders have which linters enabled, etc.
Sure. Thank you.
Yep.
Any more questions?
I had a small question. So is it possible to enable this like across projects, not just for one project? Let's say later.
I mean,
my ID for
are you using a mono repo?
We are using multiple repositories for like Microsoft.
Multiple repositories is different from a mono repo.
Okay. I mean, it's not a mono repo. It's multiple small services, and I don't want to basically configure it for all the services. I don't want to
I don't know of a way that you can do that as of now. I mean, like not everyone might check out those repositories. Maybe you could do some work to basically write a tool which will pull the configuration from a single place. But you would have to do that work yourself. There is no support, as far as I know, in Golangci-lint for applying a single configuration across all repositories. Sorry? Pre-commit hooks are going to be at a Git level, right? Yes. Oh, you could also have it at global level. That is right. Yeah. You could do that, but the configuration would still have to be present for each. Yeah.
So is there any config in lint that makes, so I want to check, I want to lint the new code, not the past code.
Yes, that is exactly what I explained here, right? So, sorry. So this particular flag, new from rev, will only report issues for new and modified lines. It will not report issues for lines which have already been present with issues. It will report the issues only for the new and modified lines. If let's say you raise a PR and it has 2 new files and 1 file which existed before has been modified. It would report all issues for the 2 new files, and for the file which was modified, it would report issues only for the lines which are modified. There could be other issues present in that file, those won't be reported. Only the functions and lines which are modified, for those errors will be reported.
Okay, thank you.
So you can take the questions later. Yeah. Thank you, Suhas, for your talk on linters.
Yep.